Hello everyone. Today I will show you how to do exploratory data analysis on a Pandas data frame in just 3 lines of code. We're going to use a powerful library called Pandas-Profiling. It's very simple to use. All we have to do is give it a Pandas data frame and it will create a report showing visuals and statistics for each column. Before we get started, we obviously need to install the package. The preferred way to install the package is using pip install. But there's also a Conda package if you prefer using the Conda package manager. I'm now in a Jupyter notebook. I've imported pandas and created a data frame called DF. This dataset has a lot of loan data, where each record in the dataset corresponds to a loan application. So we have information about the loan, such as the loan purpose, interest rate, and installment, and we also have information about the borrower, so things like the DTI, debt-to-income ratio, and credit score. Now let's suppose that we are a data scientist and we want to create a model that makes predictions about loan applications. Well, before we create models, we first need to do some EDA, or exploratory data analysis. We need to have a good understanding of our data set before we make any sort of models. So we can do a quick and simple EDA in 3 lines of code using the Pandas-Profiling library. We first need to import the library. Next, we need to create a report using our data frame, and then finally we need to render the report in the Jupyter notebook. So I've already run this cell, and this is the output. So we get a widget that's interactive, and we can click around and explore. So let's first take a look at this overview section. So here we see some high-level information about the dataset, so things like the number of variables, if there are any missing cells, if there are any duplicates, and the total size in memory. Next, let's take a look at the warnings section. So this also gives us some high-level information about the dataset. So the first section here shows feature pairs that have high correlation with each other. So for example, here we can see that interest rate is highly correlated with FICO. And there are a lot of other features here that are highly correlated with each other. Next, there's a section on missing values. So we can see here that purpose has 1,000 missing values, or roughly 10.4% of the column is missing. We can also see that DTI has 16.3% missing values. So this is important to understand because maybe your reporting requires a certain variable, and if this variable has a high percentage of missing values, then maybe that's something you need to investigate further with the source data. Next, there's a section on zeros. So this is what portion of the data contains 0 values. So we can see here, for example, this feature called pob.rec has 94.2% 0 values. So this is not necessarily a bad thing, but this is important for you to understand, and you may need to investigate further. So next, we can go to the variable section. So the variable section lets you dive deeper into a variable and see some statistics and get a visual. So let's take a look at interest rate. We can see here some statistics about interest rate and visual. We click on toggle details so we can see a better representation of everything. So there are 4 sections here. We have statistics, histogram, common values, and extreme values. So statistics will give us a list of summary stats for this feature. So we get the quartile range, the mean, median, max. We also see the standard deviation and variance. If we go to histogram, we can see the distribution of the interest rates. The common values will show us the most common interest rates in our data sets. And finally, the extreme values will tell us what are the lowest and highest interest rates in our data set. So we can explore this for multiple variables. We can see whichever one you want to explore. Next is the Interactions tab. So the Interactions tab lets you see the relationship between 2 features. So for example, let's say we want to look at interest rates and FICO. So at the top, I'm going to select FICO, and in the bottom here, I'm just going to keep it at interest rate. So here we can see that there is a negative relationship between FICO and interest rate. As FICO increases, the interest rate decreases. Also, this plot is color-coded, so if a point has a deeper shade of blue, that means it exists more in the dataset. So for example, this point here is dark blue, and this point corresponds to a FICO rate, or a FICO score of about 700, and an interest rate of about 0.13. So that means that this data set has a high number of observations or loans with a FICO score of 700 and an interest rate of 0.13. And like you can choose multiple, or you can choose other features and see the relationship and explore. So next there is the correlations tab. So the correlations tab shows a correlation matrix of all the features in our data set. This is also color coded, so if something is darker blue, that means there's a high positive correlation. If it's dark red, that means there's a negative correlation. If we focus on this cell here, this cell corresponds to the correlation between interest rate and FICO. We can see that it is dark red, so that means this has a high negative correlation. And we can also confirm this by going back to the interactions tab and seeing the interaction between interest rate and FICO. So once again, we can see that this has a negative relationship. If you go back to the correlations tab, there's a button to toggle correlation description. So this lets you see how the correlation metric is computed. So in this case, we're looking at Pearson's R coefficient, and it has some information about this. Now suppose you want to use another coefficient metric to compute the coefficient matrix. So right now we're looking at Pearson's R, but we can select Spearman's, we can select Kendall, you can select whichever one makes sense for your data set. Next, there is the missing values tab. So this plot here shows the proportion of non-missing values in a data set. So we look at this one, this is credit policy. This one is at 1.0, that means all values of credit policy are non-missing. However, if we look at purpose, we can see that its value is roughly 0.9. This means that 90% of all values are non-missing, and then 10% of the values are missing. A better representation is the matrix view. So this tells you what portions of the dataset contain missing values for a specific row. For example, if we look at DTI, all the horizontal white bars represent a section of the dataset with missing DTI values. So this is an interesting view because if we were to have a dataset with portions that are missing values for multiple features, then there may be an issue with our dataset, and we'll have to investigate further. Finally, there is the sample tab. So this is pretty straightforward. We can see the first few rows of our data set and the last few rows of our data set. To quickly summarize, Pandas-Profiling is a very easy way to conduct an EDA. It only takes 3 lines of code and you have a full report that describes your data set. This is a very useful tool for data analysts and data scientists that can quickly understand a new data set and move on to their own analysis. This is also useful for data engineers because they can use this tool to look for any sort of data quality issues on incoming source data. One thing that I did not mention in this video is customization. Pandas-Profiling offers a lot of extra ways to customize the report. I encourage you to explore the documentation and find customizations that fit your needs.